let's do the language model. We're going to talk about language models in general. You heard everywhere probably LLM, LLM, LLM. What is a language model? So a language model is an area, it's a cornerstone of NLP, natural language processing. And what we're trying to do is we're going to use the language models in our routine without, like, we're using it essentially without realizing. We're, as humans, we're using language, to communicate, but we're trying to do that for machines. We're using that in like with machines right now. We're talking about speech recognitions. We're talking about machine translation, sentiment analysis, text suggestions like autocomplete and things like that, parsing tools. And essentially what these LMs are doing is they're NLPs that are generating a probabilistic statistical model that determines the probability of a given sequence of words occurring in a sentence based on the previous word. That's exactly what we're talking about so far. We're taking words and we're just outputting words one after the other, right? So it's a distribution of probabilities of the next word. Okay, so what does that do for us? Large language models now, it's a part of the NLP still, right? We went from large language models to large language models. So large language models is a type of machine learning model that can perform a variety of NLP tasks, like we said, but specifically generating and classifying text, conversationally answering questions, translating text from one language to another. And large language model, it refers to the number of parameters in the model that we can change autonomously. So parameter changes kind of as it learns. And you might have heard like, oh, Google released a 7 billion parameter thing or model or things like that. That's where it's coming from. That part of the large language model is the number of parameters that we have. LLMs are trained with intense, and I cannot emphasize that enough, intense amount of data, and they use self-supervised learning. Earlier, we talked about unsupervised, supervised, and I mentioned quickly self-supervised. Some texts, like some inputs that they're getting, are raw from the different places, but they can do self-supervision and try to label the text as they go. So, so they do that process and they go and they look at all the data and they just process it and learn. And what are we trying to do here with large language models? Before we get into BERT, large language models, we have chatbots like ChatGPT for building conversational discussions. We have, like, you go on someone's website and they have a chatbot that's prompting you and you want to discuss with its limitations and its defaults, and we'll talk about biases and things like that, and problems with data sets as input. But you can have a bot that does that. You can generate text, say, I have a product and I want descriptions, I want blog posts, I want articles about it, and I can just generate it using LLM and say, hey, given these criteria, generate something for me, generate that text, generate that product description. FAQ, so answering frequently asked questions and routing customer inquiries. That's a simple one when you have those bots on your banking application or stores that have online presences and you're talking to the bots to get routed to a human sometimes eventually because they can handle everything. That could be useful. Um, and so we're talking about the e-commerce example earlier with that big company that is doing product and gathering feedback from customers and from their reviews, from emails, from social media posts, from different sources. How do you analyze the customer feedback and just process it in a pipeline and just do that scale? That is an interesting problem to use LLM for. Translation. So that one pretty straightforward. We talked about translating from one language to another, um, sometimes from image to text to a different language, like you might have seen on Google Lens when you have your Google Translate camera on your phone and you highlight a text in a different language and it can automatically change the text in an image to the different language. That's what that can be used for, using Google Translate, for example, under the hood. and classifying and categorizing like large amount of text data to, like we were talking about the articles earlier, like the news articles. So, okay, now let's take a pause from LLMs and talk about transfer learning. If I have a large language model and I want to train it and to do a specific task off of another model that already exists, that's what I would be using. So here it says techniques where a deep learning model trained on a large data set is used to perform similar tasks on another data set. It is better to use a pre-trained model as a starting point to solve a problem instead of building it from scratch. I think that's pretty straightforward. You do not want to, well, you could, but it's preferable to just start from a point where you have already spent the computation power on an existing model and then transfer that into your data set to fine tune it or to do something special about it. Where can we use it? Well, I just brought up a couple examples, but machine learning models that deal with NLP can be trained in a variety of ways by using transfer learning. So if I take the base model of GPT-4 and I want to use it for my company's intranet and their internal documents so that onboarding becomes easier, I could go off of a nice model like that and then transfer that learning to fine tune it potentially. This is just the architecture of how you would do it. In a traditional ML, you have a task and you have your model and you can output that type of model. And for a different task, you have a different model and you do that specifically for that different model with a different data set. But with transfer learning, you can take that knowledge and just transfer it and just not have to train everything, which is pretty convenient.